Hi, this is Shane, and this is a video for Lab 3. In this lab, we're gonna talk about the datum planes, datum coordinate system, and we will introduce some design features like mirror feature, swept. And then we will introduce how to make the project parts spring and the top blade. So spring is here, and the top blade is here. So this project parts will be in part 2, and the homework will be only the spring. And if you have enough time, you can start doing the top blade, because I looked into the schedule. You should have half of the top blade done by the end of this lab. Okay. Alright, so datum planes are, if you remember, our sketch should be built on the datum plane or solid face, the face of solid. So the datum planes, they basically the reference planes that you will build your sketch on. So we have two different type of datum planes. We have relative and fixed. You can modify them by uncheck or check this box, but usually we just use relative datum planes. Okay. So how to build a datum plane? We have a couple different options. Here is the way you can build a datum plane, datum axis, and datum coordinate system. So let's pick this first. And then, as you can see, there's the dialog box. We have a lot of different options, but basically inferred is like you choose what you pick. So if you pick this face, okay, your datum plane will be on this face, but you still have the option to offset the distance of this datum plane. Okay, you can type in the number, or you can just drag this handle. Alright, so basically at distance is just a more specified tool for the datum plane. So if you click that plane, that will give you the distance option. Okay. So the next one is at angle, which is a little bit tricky. You should choose first the planar object, then you should choose the axis. So let's say if I want a datum plane that's at 30 degrees away from this plane, so we can pick this plane first, then we pick which axis we want to be. Okay, we can use the top, and as you can see, this datum is 30 degrees away from the planar object we just picked. So you can either drag the handle, or you can type in a number, 30 degrees. Okay, so that's pretty easy. Just remember how to pick the which plane or a line or edge to pick. Okay, so the last one is on curve. Let's see, what's the curve? Okay, if we have a spline, let's say, if we build a spline, let's build a sketch first on the XY plane. So if we have a spline, this is the command to build a spline, or you can use an arc or anything. Okay. So what if I want to have a datum on top of this spline, and the datum plane is normal to the curve? So that's the option on curve is for. So on curve is here. Okay, first you can pick the curve, and as you can see, the datum plane is always normal to this curve. And you can define the position of the datum plane by arc length or the arc percentage. So percentage is pretty neat. 25% will give you a quarter distance, a quarter length of the overall curve. And you can choose normal to paths, or you can even choose tangent to paths. So you can see this is always tangent. That will give you a lot of possibilities. Okay, so you can play around with these options. That's the way we build a on curve data. Alright, so since we have the data planes, we can also create data coordinate system. And if you noticed, every time we create a new file, there's data coordinate system. Okay. That's the default, or that's the one the system already created for you. And you can, if you have something like this or something like this, you have a lot of features at different angle with the original coordinate system. You can just build one for all the features that will be at the same angle, will be aligned with this cylinder. Okay, so that will be much easier for you to build those features. Okay, so we can come here. That's the data coordinate system, and you have the option to use dynamic. Dynamic is basically you drag the system. You can snap to a certain point, and you can drag the handles to rotate your coordinate system. Okay, so you can also do you can define the orange, the X and Y point. There are a lot of options, and you're encouraged to try them out. Okay. Then, as you can see here, the dynamic is pretty neat, but it's not very accurate sometimes, so you need to use different options. Alright, now we will introduce some design features. We're going to introduce mirror feature and swept. So first, we did mirror curves in the sketch. We can also use mirror feature for the solid geometries. So if I have one box here, or I have a super complicated shape here, and you don't want to do that again on the other side. Okay, so we can use mirror feature. Let's see where the mirror feature is. We can go to Insert, Design Feature, and nope, should be Associative Copy, and it will be here, Mirror Feature. Okay, and that's our dialog box. First, you're gonna select the feature. It can be a solid, or it can be something like a edge blend, a hole, or some like maybe subject. Not necessarily a physical solid. You can pick something like material cutting, something like those. Okay, so first we can pick the feature. Then we need to define the mirror plane. So for this case, we can mirror the whole box to the other side of XZ plane. You can pick, let's see how to pick this one, close to the edge, XZ plane. Okay, and you can see that small little box means the feature will be at this position. Let's click apply. That will give you the mirror feature. Okay, if you want to keep doing that, we can pick 2 and pick a plane. Click apply. That will give you another multiplied boxes. Okay. Also, we can, as I said, if your geometry is symmetry, or if your geometry has enough space, okay, let's first maybe make a hole here. You can first make a hole. I think there's a point. Finish sketch. Then we can define the parameters, diameter. I'll just leave this for 1 inch, so you can see a hole there. What if I want the hole at this corner, and that corner? So we can use also mirror feature. Okay. We can pick the feature from the part navigator. Just pick the hole, and you can select the mirror plane. It's hard to pick this. Okay. That'll give you the hole on the other side of those boxes. And something's wrong. Okay, let's maybe try a different plane. Delete those. Okay, we can do this within this box. So mirror feature, mirror this feature to new plane. I'm gonna use biplane, okay, bisector to define a midplane of this box. Let me try apply. So that's the way you can mirror a simple hole to the other side. And maybe it doesn't like you to mirror this hole to the other object. Okay. So just play around with this command. You can get a feeling of this command. Alright, so next thing is the swept. Swept is very neat when you want to build something like this, very complicated shape, but has multiple cross sections, and it goes along a certain path or a certain guideline. So that's what we did in the summer semester. We have about 5 or 6 cross sections. Then it goes along this path, so you will get this kind of shape. Okay. So let's see. We have a nice curve here, and we have a datum here. We can use this datum to maybe another datum to make a swept. Let's see. Let's first build another datum for another cross section. Okay. So maybe at the end of the the curve. Okay, we have 2 datums, and then we can define 2 different kind of cross section. Okay. So for this cross section, we can use a rectangle. Okay. Finish sketch. That's the rectangle. Then for this one, we can use a circle. Let's see what happens when you try to put a transition between them. So I want this to be close to the guideline, center of the circle. Okay, now we have 2 cross sections. See what happens. So swept is here on the surface command toolbar. You can, if you could not find this, you can use command finder too. Okay, so we're going to use this. Alright, so first you have the sections tab. That's for the cross section. Here is the rectangle and the circle. Then the guide or this curve in this case, and in the slide that will be this arc. Okay, you can have 3 maximum to define the shape of your geometry. Alright, so let's expand this first. Okay, so if you want to choose the cross section, once you pick the first cross section, you don't pick the second right away. You need to press this button to add a new set. Okay, so each section will be a set in this tab. And you also have the curve rule here to select connected curve or tangent curve, okay, and the other options. So we can add a new set for the circle and click this. And also, if you look clear, here is you can define the direction like this, and you can define the orange curve of a cross section. So for the for the circle, you can't define the orange because it's by default it's here. But if you want the scan to be nice and match each other, you want first the direction of the cross section should be the same. And if you look at here, this is counterclockwise, and that on this direction, that's actually clockwise. And remember, this thing scanned along the path, so these 2 directions should match each other. So I want to reverse the direction of the first section. And then if you look at the starting point, this one here, that one is on the left side, and the circle is actually on the right side. So I want to define the origin curve to be this one, okay, and a different direction. Okay, then I'll pick this one. So now the directions are the same, and the origin curve, at least they are close to each other. Okay, some of them define the guideline in a second. So we can pick the guideline. Right away you can see the shape. And as you can see, the starting point is here for this section, and that point scans along the way, goes to the middle of this circle. So the scan point will be matching each other for different sections. And for more complicated shape, sometimes you have to manually define the scan path. The scan point. Okay, so couple options here. You have the linear option and cubic option. If you zoom in here, you can see there's a sharp edge. Okay, and look, if I change that to cubic, the whole thing will be a little bit smoother, but not that much, because this edge is from the corner of that rectangle. Okay, and you can even have the bi-point alignment. If you use bi-point, you can see there's 4 points here, and there are 4 points here, and there's line connects 2 points. These 2 points. So that means that these 2 points are aligned. And for complicated shape like this, sometimes you have to manually move those points up and down to change the geometry to the ideal case. Okay. So since we are not using that complicated shape, I'm not going too deep on this. Okay. Alright, so for homework we are doing the spring for the project part, and the blade will be left for Lab 4, and I recommend you to finish this within this week, or at least you finish half of this, because we still have two big parts coming. Okay. All right, let's start with the spring. So the spring will be in part 2. Okay. Well, I'll stop here.